carbon and how it interacts with other carbons and how it interacts with other atoms. So if you watched the video last night, one of the things about carbon is this, right? You can, if you have a carbon, a single carbon, right? It's got 4 bonds. That's a hallmark, right? Always 4 bonds, right? And it can also have different geometries or different shapes. So a carbon like this with 4 bonds to it is going to be, it's going to be the shape of a tetrahedral. Sorry. Let me minimize this and get this out of the way. All right, it's going to be in the shape of a tetrahedral. Right, but the beautiful thing about carbon is that it's such a versatile atom. You can do so many different things with it. Right, so not only can it form these 4, and these are all what we call single or sigma bonds. Right, can form those 4 sigma bonds. And can somebody tell me why it wants to make 4 bonds anyway? It's something you learned in CHEM Part 1. One of the first things you learn.
Is it to fill its shell?
To fill its octet. That's right. Everything it wants to follow that octet rule, right? So it wants to have those 8 electrons around it. Like trying to match up to the closest noble gas. Isn't that what you learned in CHEM Part 1? All atoms want to match the closest noble gas to them. Right? All right. So it can form those four sigma bonds and fill its octet, but carbon is versatile, right? You can do a lot more with it than just forming single bonds. So let's say I have a carbon like this. It's coming. My hotspot is a little slow, right? Let's look at this carbon right here. Does it still have 4 bonds to it? Right?
Yes.
Yes.
You have those are sigma bonds. And then if you look at the bond here, this is what we call a double bond. All right, the fact that it's a double bond means that it counts twice, right? So for this carbon that's highlighted in pink, it's got 2 sigma bonds to it. It has a double bond, which consists of 1 sigma. I'm gonna keep sigma red. And then the other bond, the blue bond, is what we call a pi bond. I'm gonna talk about how you make pi bonds and all that stuff too in a minute. Right, so you have 4 bonds to carbon, 3 of those are sigma bonds, 1 of them is a pi bond. So every double bond is made up of what? Help me out.
A sigma and a pi.
Sigma and a pi. Every double bond is made up of, is constructed the same way. A sigma bond and a pi bond. And it doesn't matter that the double bond is between carbon, right? Because you can also have a scenario where you have like an imine, right? That double bond is the same. It's a sigma and a pi. You can have a carbonyl, right? That double bond is a sigma and a pi. Let me give you the name too, because might well throw some functional groups in here while we at it. So that's a carbonyl, and this is what we call an imine, right? All those different functional groups in a carbon double bond, we call it an alkene. All right, I'm kind of compressing this because I know the semester is the same length, but it's gonna go by quick because I'm just having a hard time wrapping my mind around the fact that after Thanksgiving break, we're done. So I'm gonna compress this and kind of hit the topics as they come up. And then after we get the foundation down, then we're gonna, push through the rest of the material. All right. So you got double bond that's made up of a sigma and a pi. And every carbon is always going to have 4 bonds to it. That's something that you should not forget. If it's a carbon and it's neutral, it should have 4 bonds to it. The only exception is something called a carbene, but we'll talk about that later. All right, so you can have a double bond. It can also make triple bonds, right? So this carbon right here, how many bonds does it have to it?
4.
4. Always got 4 bonds. You can count them up. The triple bond counts 3 times. The bond to hydrogen counts once, so it's got 4 bonds. But if you look at it, right, it only has 2 groups around it, right? The H over here is a group, and the carbon over here is a group. If we're looking at the one that's highlighted in pink. So you got 2 groups, but 4 bonds, right? This carbon, this type of carbon, when it has a triple bond to it, we call it an alkyne, right? But the basics stay the same. You always want to fill the octet rule. So you have a triple bond, and that triple bond, let me clear this up too. I'm gonna go back and use the same concept we used earlier. So our sigma bonds were red. So you got 1 sigma, and then the pi bonds, I'm gonna make those in blue. All right. So every triple bond is made up of 1 sigma and 2 pi bonds, right? So you have here you have a sigma bond, right? And then up in here you have a sigma bond, and then 2 blue bonds are both pi bonds. All right. Any questions about that? So a triple bond is made up of what? 1 sigma and 2 pi's. Are you following? Yes? No?
Yes.
Maybe?
Yes. Yeah.
All right. So good. So we got carbon. We know it's special. It can do a lot of special stuff. I'm going to talk more about how it can make chains and rings and all that stuff in a minute. But I want to go back and talk about another aspect of this, these carbons, and that is the fact that if you see a carbon with 4 bonds to it, it should, that's really counterintuitive, right? If it's got 4 bonds, because let's talk about that. If carbon, we think about the electron configuration of carbon. Anybody remember that electron configuration? What is the electron configuration of an atom? Anybody? Don't just jump in. I know it's Friday, but feel free to speak your mind.
Is that the one where you have to do like the SP and all that?
Yeah. So the electron configuration is basically how the electrons are arranged in the orbitals, right? Right. And so if you remember from CHEM, you have s orbitals, p orbitals, d orbitals, and f orbitals. Is that right?
Yeah.
Yes.
Yes.
And remember, the S is shaped like a sphere. You remember that? I'm gonna do my little shading right here so you'll know it's a sphere. You remember that?
Yes.
Yes.
What about the P? What's the shape of a P? Anybody remember?
Is it a dumbbell?
Dumbbell shape. That's right. See, starting off on the right foot. That's good. It's gonna be a great semester. Even though we're in cyberspace, it's still gonna be good, right? It's shaped like a dumbbell. Now, what do you know about the P as far as the plus 1, 0, minus, like the M sub L number? How many P orbitals are there?
3.
3. Good. So you have I'm gonna put that down here. PX, is that right?
Mm-hmm.
But M sub L tells you how it's pointed on in space, right? So PX, PY, and then PZ. Yes?
Yes.
And each one of those P's can hold 2 electrons because every orbital can hold a maximum of 2 electrons. Is that right?
Yes.
And then for D, how many D's do you have? There's a lot of,
10.
I'm not going to draw the D's out because there's a lot of shapes. But I can draw the P's. And then PZ would be kind of like that, like pointed out at you. All right. How many D's do you have?
10.
10 electrons total. So you got 5 D's, right? DX, DY, that's a B this Friday. DY and then DZ, is that right? And then DX squared minus Y squared and then DZ squared. Those are your D orbitals. And each one can hold 2 electrons. Right? And then F, how many? 7?
Yep.
Yeah, 7.
So if you remember from CHEM, right, all of these orbitals are organized in a certain way, right? What's it called? Anybody remember?
Shells. They
Right.
call shells.
Is it the, yeah, you're right. They're organized in shells. That's right. But it's called an outbound buildup. You remember that? 1S. Come on, finger. 2S, 2P, 3S, 3P, 4S, 3D, so on and so forth. Do y'all remember that little organization of the shells?
Yes. Yes.
Yes.
Yeah. Is it all coming back to you?
Uh-huh.
Let me do some magic. Let me hear it. Here, have some tea. Take a sip. It'll all come back. Yeah. So the outbound buildup tells you how the orbitals are organized in any atom, right? And that's how we determine what the electron configuration is. And each of these can hold 2 electrons in S, right? For P, you can have a maximum of 6. Is that right? Because each P has 2 and it's 3 P's. So you can have a maximum of 6.
Yep.
It's gonna all come back. I promise by next month. It's gonna be there. And you can have 10 in the d orbital, so on and so forth. The beautiful thing about carbon is that you stop here, right? Somebody tell me what the atomic number of carbon is.
Is it 6?
Is it 6? Yeah, it's 6, right?
Yeah.
Sure.
You said sure.
Yeah, it's 6.
Let's just move on, sir. Hurry up. All right, so it's 6. So what is the electron configuration for carbon? What would it look like? 1s2, is that right?
Yeah.
2s2, because I gotta fill up each energy level. I have to fill it before I can put electrons in the next orbital. Is that right? What's that called? Anybody remember from GChem? So if you slept through,
Last part again.
say again. Oh yeah. So I have each energy level. Every time I go up an energy level, I have to fill up the energy level that I'm in before I can move to the next one. Right. So I can't put 1 electron in 1s and then 1 in 2s. If I have 10 electrons, I got to put 2 in the 1s, 2 in 2s, and so on and so forth. So what's left? If carbon has an atomic number of 6, what's left if I got 1s and 2s? How many electrons do I have left?
2.
2. Let's do a little math here.
2p2.
Is that right?
Mm-hmm.
So 2p what?
2.
2. Now, that's great. Hopefully everybody is on the boat. Let me see. We got 35 people in here, and I think we got more than 35 enrolled, but it's okay. I'm gonna figure out a way to chop this section up too, so that we can have less people per session. because I think you get more engagement that way. So this is my electron configuration for carbon. Are y'all following that?
Yeah.
What's the problem with that? Let's think about this now. Let's go back up here to our examples. We're going right back to here. How many bonds does that carbon have?
4.
4 bonds. How many bonds does this carbon have that's highlighted in pink?
4.
4. Okay. How many bonds does this carbon have right here, highlighted in pink?
4.
4.
Does that make sense to you based on what you know about how bonds are formed?
Yes.
It does? How do we make, okay, so let's back
shit.
up. How do we make bonds? Anybody?
By sharing electrons.